Welcome back. We are going to solve the problem that we did last time using the MATLAB. So remember, we had a system in which we found the output response given the input was the unit step function, and we had the output response in terms of the S-domain as 1 over s plus 4, and of course if there is a unit step you take the Laplace of that, and that becomes 1 over s. So C of s would be equal to, here we go, we can write it in MATLAB now. C of s is equal to 1 over s times the s plus 4. Okay, so here we go, and we're going to suppress this because we'd like to take the inverse Laplace transform of that. So C is equal to I Laplace is that command in MATLAB to take the inverse Laplace transform of this, and still would like to suppress this guy so that we can have it in a printable format, right? So we can say that now pretty C, and the expected answer should be like we did last time, 1 over 4 minus 1 over 4 e to the power of negative 4t. That will be the output response of the system in time domain given the input is the unit step function. So here we go. So that was expected, right? So that's what we get. Now we would like to do the plot of this output response that we got, and we are expecting kind of an exponentially rising function, if you will. So as you can see, at t is equal to 0, it is going to be 0. So let's say we are going to give a range for t. In order to plot, we can say t 0, oops, not o, but 0, colon 0.01, and going all the way up to 3. And I'm going to suppress this. If I don't, you will see like 300 values being spitted out on the screen, and would like to have these many values to get a smooth curve. So here we go. So, and now we are going to plot this. So to plot something in MATLAB is a very easy command called plot, and we want to do time, and you can see x comma y. So t is the horizontal axis here, and we are trying to plot that equation. So we're going to put that equation in there. So that will be 1 over 4 minus 1 over 4 star e to the power, well, exponent we can put, minus 4 star t. Make sure you put that minus in there, otherwise the graph will go the other way around. So let's see, did I close everything? Yeah. So now let's see what happens. Expected response should be somewhere around t is equal to 3. It should be getting up there to 0.25, right? So let's take a look at that. And sure enough, you can see the graph. Let me bring the graph here. You can see it at 0 is 0, and it goes all the way up to 0.25. So this is the system response, output system response, when the unit step, when the input is unit step, and we first initially had a differential equation for the system. We transformed that equation into the S-domain, and then from there we went from the transfer function to get the output response in time domain, and here is the plot for it. So thank you, and I'll see you in the next video. Thank you.